Hi guys, welcome to today's recording. We are going to go through the alcohol reactions today. So, just remember we're looking for this particular functional group when you just have carbon bonding to an OH group, and this is when you have an alcohol with the suffix of OL. So one thing to go through this rather quickly, alcohol is, these guys are, this out of the way. Alcohols are soluble in water. Okay, so you can definitely dissolve that in water, and that's assuming the chain is short chain. So what it means, like if you have carbons, if you have like an alcohol with 20 carbons, it's less soluble than the alcohol with 4 carbons, for example. So the more carbons there are, the less soluble it becomes. Okay, and it's normally colorless. And it's nothing really special. It can combust as well, so just like your what's that called, alkenes, alcohol can also burn, which is fairly common. Otherwise, how would you get the old school what do you call those, alcohol burners before before electricity was a thing? Okay, so with the alcohol, we're just gonna go through some of the stuff now, some of the reactions. So alcohol does, let me quickly think, 3 types of reactions. Okay, so it does 3 types of reactions. So the first and easiest one to do is substitution. All right, so we're just going to do substitution. Substitution is when you substitute one group of molecule or one group of atoms with another group of atoms. So in this case, like say for example, you have CH3, CH2, OH, and there's only one reagent you need to learn for this. Well, one of 3. You can just pick one. So if you use PCl3, PCl5, or SOCl2. Okay, so what it means with these guys is that you pick one. Okay, you pick one. You can write 3, but you just need one of them. And technically, ethyl chloride SOCl2 is the most correct one. And I personally always go with that, but it's one of those 3. If you see PCl3, PCl5, SOCl2, they categorize the catalyst the same reaction. I mean, this is again where I would like to ask you to understand the reaction and make an educated guess on what the product's going to be, because I don't want you to, it's a lot of work to actually fully memorize everything. I mean, if you think about it, I told you this is a substitution reaction, and you should know by now that it's always a functional group that gets substituted, and all of these 3 things have got chlorine. So I hope it's not too obvious. I mean, it's not too difficult to know that this turns into a haloalkane. Okay, so you essentially just change the OH to Cl, and this is where I would bring back some of the stuff that we've done previously. So how do I turn this back? All right, how do I turn the Cl to the OH? And hopefully you remember this. You need your KOH AQ to do this substitution. So this is also substitution. Okay, so this is the back and forth of the alcohol and the haloalkane. But with the limitations of this particular unit, we are only interested in the chlorine substitution. So we're just limiting now, restricting the number of choices. So we're only picking PCl3, PCl5, or SOCl2. All right, so this is the easier one. Let's do the next easy one, which is oxidation. Okay, so this is not fully correct if you're here to, if you're like an older student, if you already learned about aldehydes and ketones, which are functional groups, not appropriate for this particular year group. But if you're interested in if you already done aldehydes and ketones, then you know that this part I'm doing right now is not fully correct. But this is learned aiming at NCEA level 2, so aiming at some of the students doing year 12 chemistry. Okay, so oxidation, we first need to look at, let's give you some examples. So again, this one, So I want to make that make that really clear, so you don't come back and say, hey, you told me that this doesn't react. But you know, if you're someone that's already done this, then you should know this. Okay, so similar to your haloalkanes, I hope so we can look at the degree of alcohol here. So this OH group is bonding to a carbon that's only bonding to one other carbon. So this is a primary alcohol. Okay, and then this OH group is bonding to a carbon which is bonding to two other carbons. So this is a secondary alcohol. Alcohol. All right, and this OH group is bonding to a carbon that's bonding to three other carbons. So this is why this is tertiary alcohol. So the thing that I was talking about before is that if we want to turn an alcohol into a carboxylic acid, there's only one of these three alcohols can do that, which is going to be carboxylic, which is going to be primary alcohol. So if you do, if you use Cr2O72 minus H plus, or if you use MnO4 minus / H plus, so these are the common oxidants that you did in redox. So this will give you a color from orange to green if something happens, and then the MnO4 minus will give you from purple to colorless. Okay, so hopefully you already written this down so many times that you're so familiar with the colors, you're gonna remember this. Okay, so that's from orange to green, and the other one's from purple to colorless. And what's going to happen is this is F1O, and that will simply turn into the carboxylic acid. Okay, so you keep the OH, you can see the OH is kept, but what's going to happen now, what has happened is that you lost these two hydrogens and then you gained an oxygen. So another way of explaining redox, you know how we can always talk about the electron transfer, oxidation number change, but oxidation reaction is when you gain oxygens and you lose hydrogens, and this perfectly fits the criteria, right? Because I've lost the two hydrogens, I've gained an oxygen, and that's oxidation reaction. And it's really important that you understand that only primary alcohols can oxidize to carboxylic acid. Okay, so and then if you do more carboxylic acid, and if you do more chemistry later on, then you will know that primary alcohol can turn to aldehyde, which turns to carboxylic acid, and secondary alcohol can be further oxidized as well. But this statement right here is fully correct because only primary alcohol can turn to carboxylic acid. Okay, so and why is that? You have to understand that, you know, carboxylic acid is COOH, right? So this part here, right here, this is non-negotiable. It has to look like that. There's no other option. So, and then if you look at the structure right now, can you see this OH is only bonding to a carbon that can only bond to one other carbon maximum? So that means this OH stays and there has to be two H's. And then this only bonds to one carbon, because what's going to happen is that those two hydrogens will be lost, and then you gain the oxygen in the form of a CO double bond. Okay, so that's why only primary alcohol can be oxidized into a carboxylic acid. And we can do another example. So it doesn't matter what I have on this side. I can have CH3 here, I can have CH3 here, I can have CH2, CH2, OH. So as long as you have a primary alcohol, so the OH group is bonding to a carbon that's only bonding to one other carbon, and then you just copy everything else that you see them. Okay, so no changes, and then what's going to happen is that this carbon that I'm highlighting right now is going to keep the OH group. It's going to keep the OH group, but then it's going to lose these two hydrogens, and it's going to form a double bond. Okay, so you've gone from 3-methyl-butanol to 3-methyl-butanoic acid. All right, so only primary alcohol can do this. Because of the structure of COOH. It doesn't mean that secondary alcohol can't be oxidized. It can be oxidized, they just don't make a carboxylic acid. It has to be a primary alcohol in order for that to happen. So let's look at the what's that called? The last reaction. Now this is going to be the hard one. We're going to look at the elimination reaction. Okay, so if you have seen all my videos so far on the elimination of the haloalkanes, so if you look at the additions of the alkenes, then you will know that whenever there's an elimination reaction or an addition reaction, we are involving either breaking or making a CC double bond. And when you do that, there are often two products unless the structure is symmetrical. Okay, so with the elimination, so again, this is making CC double bond. So for example, if I have an alcohol that looks like that, CH2, CH3, okay, so butane 2O, and then this is the ingredient we need. We need concentrated H2SO4, and it has to be this guy. Okay, so concentrated H2SO4 is known as a dehydrating unit, dehydrating agent, and what it does is that it removes water from the molecule. Okay, so let's think about elimination again. So elimination reaction creates a CC double bond. All right, so what it does is that, again, remember that this functional group has to go. Non-negotiable, because that's what functional groups do. That's where the chemical reaction takes place. And then, similar as the elimination reaction of the haloalkanes, we need to take away a hydrogen from the neighboring carbon. So that means we have to, so what are the neighboring carbons? So it's this one and this one. So that means we have to take away either one of these hydrogens or one of these hydrogens. And that's why we have got two products. Let's just say, you know, I'm not trying to figure out major minor yet. I'm just gonna pick, like, say if I pick this carbon hydrogen here, so I'm gonna get rid of that hydrogen. I'm gonna double bond here, and then I'm gonna copy everything else as I see it. Okay, and then I'm gonna do this one. I'm gonna remove this hydrogen, and so that carbon on the left is safe. I'm gonna do the double bond here in the middle. Oops, that's a single one. And so CH3. Okay, so how do you know which one's major, which one's minor? You look at these two carbons. So this carbon right there, this has less hydrogens. So when we are eliminating, remember poor gets poorer, but don't write that in the exam. It has less H's, so therefore more likely to lose another H. Okay, so it's more likely going to lose another H. So when that loses another H, which is this one. All right, so this is major, this is minor. Okay, so let's do another one. So let's go through another example here. So if I have CH3, CH2, COH, HCH, let's put a Cl here. Why not? Why not? Okay, so this is 2-chlorobutane pentane 3O. So again, if I do this reaction of conc H2SO4, so this is where you just need to remember. Okay, so when you see conc H2SO4, that means you eliminate the OH. Okay, so it's not the Cl, because conc H2SO4 is the required catalyst to do this elimination reaction with your alcohol. Well, if I change that to KOH alk, then you remove the Cl. Okay, but in this case we don't, because that's not the reagent that's being given. So we need to look at this carbon that has got the OH bond attached to it, and we need to take away a hydrogen from one of these neighboring carbons. Okay, so you can already see that this carbon right here, this has less H, so it is more likely for that hydrogen to lose that another H. So let's draw that on the right hand side, okay, because the double bond forms on the right hand side. Why not? So that means I lose this H, and I double bond here, and that's CH3. or I can make the major minor product. So this is major, or I can do the minor product. I lose that H that I just highlighted, and it's just gonna double bond there, and then everything else stays exactly the way they are on the other side. Okay, so it may take a little while to get used to this, but you know, this is where it kind of falls into place. Okay, so that's the 3 types of reactions that alcohol does. It does the elimination reaction as we described, it does the oxidation reaction, and it does the substitution reaction. Now this is where is a really good place to kind of show you what we've done so far. Okay, so this is where we can actually go through an example to show you what a flowchart kind of looks like. Okay, so we're just going to give you a simple one. Let's just go through. Now, there's a part that I definitely forgot to cover, but which I'll do right now. So let's do it right now. So this is. Let's just keep it simple. Okay, so this is propane. Now, if I want to turn this into a propane, which is an addition reaction, can you see what I've done here is I have broken the double bond, then I added an H onto this carbon, and I added an H onto this carbon. That's where the H's come from. So this reagent is going to be H2/platinum, or sometimes nickel 150 degrees. Those are the catalysts. The key thing that we look for is the hydrogen, because the hydrogen is being added. The hydrogen is being added onto those 2 carbons. So this is addition reaction. Okay, you're not going to add the platinum. Please don't add the platinum. The platinum is simply a catalyst for this reaction. So if I go from this alkene, let's say for example, if I want to add H2O/H+, you know, the diluted H2SO4, the thing that we talked about with alkenes, hopefully you can see that we are going to make 2 products. We are going to make CH3CHOH, CH3. We're going to make CH2, we're going to make CH2OH, CH2, CH3. So again, this is addition reaction, because what we have done is that we have broken the double bond, and then I added the OH on the carbon in the middle, and then this one I added the OH on the carbon on the left, and the other one gets a hydrogen, right? So which one's major, which one's minor? So we are doing addition reaction, rich gets richer. So hopefully you can see that this CH2 is richer. So this guy has 2 H's, this guy has 1 H. So that means this carbon that I'm highlighting right now should get another H, like this one has done. So this one is major, and this one is minor. Oops, why am I writing major minor for the same molecule? And this is minor. Okay, now I can again do the same reaction, do a similar sort of reaction. I can do HCl. So when I do HCl, I'm also going to make 2 products. I'm going to make CH3. So for the exact same reaction like we did with the OH, we are going to make exactly the same thing, but except instead of OH, it is Cl. So this is where, you know, what happens with a lot of people that do organic chemistry, they do this and they go, oh, this makes sense, this makes sense, this makes sense. But if we put everything together, and that really tests your knowledge on your understanding of organic. Okay, so you can see that this is a secondary alcohol, this is a secondary haloalkane. So that turns into that. You need KOH AQ. And to go this way, to go back, so it may look a little bit messy, this is where you need, let's just say SOCl2, the one that we talked about today. Okay, and then you can also turn this back to that by using conc H2SO4. Okay, again, the reaction that we did today. And then one thing that we can do, how do we turn this guy back to that? You use KOH alk. All right, so hopefully this is still making sense. And then I can turn this alcohol, if I use MnO4 minus H plus, this is where I recommend you. If you're getting confused, you know, pause and then go rewatch some of the other videos that are recorded for you. Okay, so this is where you are going to have two OHs, and then you make a diol. And then the other thing that we talked about today, so you should identify this guy here as a primary alcohol. So that means you can put that with the MnO4 minus / H plus, or the Cr2072 minus H plus, and then you are going to make the carboxylic acid. Okay, so I hope this is not too overwhelming, but we got to a stage where I can actually give you flowcharts, because you know, this is where you have done a bit of everything. You know what turns into what. You can turn alkane to haloalkane. You can turn haloalkane to alcohol. You can turn alcohol to carboxylic acid, for example. Okay, and then here I forgot one thing. I can turn the amine. This halogen. Have I done the amine? Yes, I have. Done haloalkane. So you can do this with NH3, concentrated NH3 in alcohol condition. And what that does, you just replace the chlorine with the nitrogen, with some hydrogens. Okay, so this is flowchart, and then you often just get entire question just of flowcharts. So it's really important that you do know how to do these, and you know, it takes a lot of practice. So you know, I personally don't want to teach in the way that haloalkane turned to alkane by using this, alkane turned to alkene using this. You know, that's you can memorize that, but that doesn't help you. The best way is to draw an alkene in the middle and see if you can do the major minor products with different types of reactions. Okay, so the easiest ones that you could use, and like propane is literally the easiest one that give you major minor products. If you want to make it a bit longer, you can do but1ene. You know, can you do what I did just now? You know, by doing the major minor products, can you interchange them from one to another? And then you can sometimes even add a branch. But once you've done it once, you know that it doesn't matter what I do. Like I can add branches, I can add random things into the molecule. It doesn't matter, because the only thing that matters is the functional group. Okay, so as long as you know what the functional group does with the different types of reactions, with the different types of reagents, then you are going to do really well for this particular subject. Okay, so I hope that was helpful, and all the best, and I'll see you guys next time. Bye bye.